find some. So make sure you have your calculators ready to go. So the first thing I want to make sure, because if a grade 12 student use your calculator, you need to make sure your settings are set to degree. So at the top of your screen, it should say degree. If it says radians, we're gonna have to change that. So I'm gonna show you how to do that. So you just press mode, and we're gonna go to the, the fourth line, and just make sure if radian is highlighted, you just go over to degree and hit enter, and make sure it's switched to degrees. That's probably the most important thing for this unit. And if it says degrees in there, you're good to go. Okay. Everybody has it set to degrees, right? Because your answer will be different if you don't. Okay. Another thing I want to tell you about, like, I just ended up combining chapter 3 and 4. Chapter 3 in the textbook is exclusively dealing with acute triangles. Chapter 4 is obtuse. And I actually will deal with both of them right off the bat. There's a problem with obtuse triangles in certain cases. That's when we call ambiguity. We're going to leave that for the very end. There's a problem there. I'm going to make sure that once you see the obtuse triangles, which means it has an angle bigger than 90, will not have that problem. Okay, so I make sure that that problem doesn't show up. So we will only worry about that later. So I want you to know that we're combining acute and obtuse right off the bat. All right. So let's get started here. I'm gonna use probably 3 different highlighters as we go along. So intro to sine law. I'm going to tell you already, there's only sine law and cosine law. That's it. There's no tangent law, right? Sine, cosine, tan, right? Tangent. There's no such thing. It's just sine law, cosine law. Those are the only 2 you're going to have to choose from to solve any triangle. In IAPR, Intro to Applied and Pre-Cal, you learned about what we call the primary trig ratios. So that's your sine, cosine, and your tangent. Okay. It could also be sine inverse, cosine inverse, and tangent inverse. Those are to find angles, right? Primary trig ratios only work with right triangles. Primary trig ratios only work with right triangles. In grade 11 applied, that's the code for grade 11 applied, APMPR3S, we will solve oblique triangles. Okay, so maybe just a quick visual here, nothing fancy, okay? Last year, you worked with those, okay? And so this is where you use this is how I do SOHCAHTOA, by the way, if I teach it. SOHCAHTOA, like that. Because that's how the sides would be stacked, right? This is only going to be for right triangles. So they have to have a 90-degree. So it doesn't stop working. SOHCAHTOA is still very much alive and it works, but only when you have a right triangle. Only when you have that 90-degree angle. But the nice thing is sine law and cosine law does everything that SOHCAHTOA does and then some. It just solves, we're able to solve everything just using sine law and cosine law. So if you have one of these, this would be an acute triangle, or you may have an obtuse triangle. Obtuse, you have one angle that's greater than 90. All angles are less than 90 degrees. Here you have one angle bigger than 90. That's the definition of an obtuse angle. But combined, these two, like anything that isn't a right triangle, is called an oblique triangle. And so that's when we use sine law or cosine law. That's what you need to know. I want to do a little star somewhere. Also solves right triangles. So sine law, cosine law will solve a right triangle as well. Let me try to focus one more time. I feel like it's a little blurry. Maybe it's just because I'm getting older. Like okay. So here's the sine law, guys, in a nutshell. So I'm going to use this box here. Just draw a triangle. And my classic triangle looks like this. I don't want a right triangle, so I kind of make it offset a little bit. Kind of like that one slant is a little longer than the other slant. So it's not a perfect symmetric triangle. And by definition, okay, or in general, I should say, convention has it that for angles, we use capital letters, right? It could be X, Y, Z, D, F, it doesn't matter. We're going to stick with ABC. And then the side across capital A, like this angle, will have lowercase a here, okay? Lowercase a. Across from C, we have lowercase c. And across from angle B, we have lowercase b. So I don't always do that. I sometimes break the rule and call the side that I want to find X. But this is your safest bet, okay? So here we go. It states, sine law states this. You ready? It states that if you were to take sine of angle A and divide that by its side, the side that's across from it, that would be exactly equal to taking the sine of angle B, let's say, in this triangle, and dividing it by side B. And that in turn would be exactly equal to sine of angle C divided by the side across from it. This is a fact. Any triangle, if you were to draw it to scale and you measure the angle divided by its side, right? Sine of angle divided by side, you would get the exact same answers. And so us knowing this fact, right? I will give you the variation of this. I like it this way, but you could flip this all. You could say side A over sine A is equal to B over sine B is equal to C over sine of C. Either one is fine, but you just got to stick with it. Like either all the sides are on top or all the angles with the sine are at the bottom. And I'm going to try this here. So this angle here goes with this side right here. So that's very important that you see that they're opposite each other. I guess we could do this here as well. And at the same time, you know what, I'm just going to highlight the letter itself because it's going to get too messy in there, right? These are also opposite each other. It's very important. That's how sine law works. And angle C is across side C, right? So I kind of want you to see that pairing. The pairing is very important. That is a pattern you will observe. Okay. Sine law works with both right and oblique triangles. That is worth highlighting. Let's test the law. This is drawn to scale. That's important that I mention that. Drawn to scale. So what we're going to do is we're going to test this. So we're going to go sine of 22.7 degrees over the side across from it is 3.74. Usually we will have units on there, but for today we're just gonna be unitless. Okay, and then the next one is sine of b. Notice that that's an obtuse angle, correct? Doesn't bother us. I'm gonna take the sine of that, divide it by 9.51. And then I'm going to go sine of c, which is over here, that's 55.9 degrees, and divide that by 8.03. Couple of things to make note of. If you were to add up all three angles, what should they add up to? 180, right? And so I hope they do, actually. I didn't check. I just trust GeoGebra. That's the software I used. I'm going to check here. I'm going to be so upset if they don't. Oof. That's close enough. Let's give GeoGebra a break, right? So there was probably some rounding issues there. 179.99, but that's okay. It's close enough. But let's figure out, let's go sine of 22.7 divided by 3.74 and write that down. So sine of 22.7 divided by 3.74. Ooh, you got to be careful here. Good thing that this came out. This is going to give you a problem if you just do that, because it goes sine bracket and then this. So I need to make sure I close the bracket there. It's sine of 22.7 divided by 3.74. So that's good to, so this is 0.103. Let's go to 4 decimals. And then we're going to go sine of 101.39, close brackets, divided by 9.51. 0.103. That rounds to 1, doesn't it? Close enough. And then the last one gives you 1031 as well. And I bet you this is because it doesn't quite add up to 180, right? It's a little off, but let's just go squiggly marks because it bothers me. You can't say they're exactly equal, but very close, very close. So squiggly is approximately. Okay, so we've tested it. It works out. Right? It works out. This is drawn to scale, just so you know. So check mark. The law works. If we have time, I'll do the proof for you. There's a proof on why we know for sure this always works. Let's keep going. Let's try to use this. So this is what I mean by sine law. This is what I would have on my study sheet. To be honest, I would just have that on my study sheet right there. Because if you know what the sine law states, you can use that property to solve anything else. Angle, side length, you name it. Here we go. For sine law to work, this is on page 3. For sine law to work, you need at least one pair. This means that you need a known side and angle opposite to it. Sine law works in the following cases. I would not necessarily have this on my study sheet because I'll narrow it down later on. But we're going to draw 3 triangles like this in each box. Like that. Every triangle has 3 sides and 3 angles. Right? Do you remember that from polygons? Number of sides equals the number of interior angles, right? But the one that you're going to know right away, let's say grab any angle you want. It doesn't matter. But let's say you know this angle, you know that there's a number in there. And you know the side across from it. And you know one more angle you choose, it doesn't really matter. What matters here is that you see that there's a pair. You see that? This is what I mean by a pair. This is how you know for sure this is going to be sine law. But this specific case is called angle, angle, side. Okay. So if you start here, you would go angle, angle, side. You know what? I'm going to do one more here. Just so you don't think it's just always going to be like that. So let's say you know this angle right here and the side across from it. Bingo, you know already this is going to be sine law. And so let's say I tell you that you also know this angle right here. You still have this pair right there. That's what you want to focus on. Angle, angle, side. The next one is slightly different, where you know any 2 sides. So let's say you know this side and you know that side, and you know one of the angles across from those sides. So let's say you know this one right here, this angle right there. You should immediately focus in on this. This is what we call side-side angle. I call it side-side angle. You could go the other way. A first and then SS next, but it spells something something I don't want to say on camera. Okay, but if that floats your boat, then you go for it. The next one is like just pick any other 2 sides. Just give another scenario, right? Let's say you have these 2 sides, and I give you that angle here. Seriously, I'll forget the SSA. I'll forget that. Right? Don't worry about it. Just focus in on the fact that this case, this scenario gives you a pair. You know you're in sine law territory. Okay? And this one is a bit tricky. The next one I'm going to give you. This is what we call ASA. Let's do that one. This one I think is important to remember. ASA. And so think of it this way. You have 2 angles known to you, and one of the sides that connects those 2 angles is also known to you. Do you see a pair here? No, right? No pair. Is there a way to get a pair? If you have 2 angles, can't you find the 3rd angle? Yes. So find 3rd angle using sum of triangles equal to 180. Okay. And there I'm going to use a different color for this. I'm going to say, hey, let's find that. Go check mark, because now we know what it is. Do you see a pair now? Yes, you do. I hope at least. There's your pair. So this is what I call this the hidden pair. Wait, I think that's empty. I'm gonna put that there. So that's the hidden pair. Remember this one. This is the one that throws a lot of students off. They think they're stuck. Don't despair. You can find the third angle. So just remember that. One more thing, because I'm foreshadowing what's going to happen down the road. There are three triangles where sine law works for. 3 cases. Okay. Should I say, yeah, these are 3 cases. Cosine law only has 2 cases that work. So most of the time you're going to be using sine law. Most of the time. Not like it's not saying that it's always sine law or always cosine law, but just remember that. So recall, the largest angle is across the longest side, and the smallest angle is across the shortest side. That one you should remember. We can verify that on the previous page. The largest angle was 101, right, or something like that degrees. And so across from it, you have the longest side if you check. Okay. Draw and label the following triangles. So if I ever ask you to say, hey, triangle DEF, and then a bunch of information, this is what you're gonna do. I don't need it to be drawn to scale, to be honest. You're just gonna draw one of these, and then just gonna start anywhere you want. Okay? You wanna start up top, you wanna start over here, it doesn't matter, but you go D, and then I go clockwise around. So D, E, F. It doesn't matter if you go counterclockwise or clockwise, as long as you put the letters there. And then angle D is 60 degrees. We put that in there. Side D is 5.2, whereas side D across angle D. So this is D here is 5.2 centimeters. Oh, there's 2 D's, right? This is supposed to be F. Angle F is 50. And side F, which is over here, is 8.3 centimeters. So there you have it. But there's something that bothers me about this one. Something not right about this one. I just told you, largest angle, longest side, so on. This is 50 and has 8.3 across from it. This is 60 and it has a shorter side, so this is actually a contradiction. So why don't we just fix that? Let's go up here and change that to an 80. Change angle F to an 80 and we'll change that. It just bothers me. Right after I said something, there's a contradiction, right? Doesn't make sense. So there you have it. That's how what I would expect you to do. So what is unknown here? This is unknown and that is unknown, right? So an angle and a side. So the rest we can find. Or that we'll calculate in a bit. So here we go. Come with me to page 4. We're going to apply sine law to an example here. So we're going to first deal with solving missing sides or unknown sides. Determine the length of side B. So where is B? This is capital B, so this is what they're asking you for. This is side A, but they're not asking for it, so we're just going to put a question mark there. Okay, so let's imagine we've already covered cosine law and you're wondering which one should I start with. you should say, hey, there's a side here and there's the angle across from it. Bingo, this is sine law. Okay, you've got a pair. Use sine law. Immediately you're going to be like, yep, sine law. Not a hidden pair, it's way out in the open, right? So we start with it. You're going to be like, okay, it's sine law, so we need to go sine of 62 degrees divided by the side across from it is equal to, and you know how we had two equal signs with three expressions? You don't do that when you solve. That is just a property. We use that property to solve. So what are we trying to solve here? We're trying to solve for side B, correct? So that's the side we're going to find out. So what should be up top here? Sine B, yes. Yes. Do we know what angle B is at this moment? Because we have two unknowns. You can't have that. We can find it, right? Using some of, so I'm going to do that real quick here. Maybe on the side here. Angle B is 180 minus 38 minus 62. Some students just go right ahead and find the third angle and get it done and over with. Even if they might not even need it, they just do it. So we take this and we plug it in there. Now it's solvable, this proportion. So we go sine of 62 over 4.5 meters. That's sine of 80 over side B. Now we can solve this thing. It's a proportion. I don't know if you recognize that. So B, to find B, we just always go to the side where the variable is, start with the number, cross multiply, then divide. Okay, so cross multiply, then divide. But I want you to show me the work, right? So it's sine of 80 times 4.5. Guess what? I always do the 4.5 and then the sine of 80 so that there's no mix between the, like you multiplying the 80 by 4.5 by mistake, divided by sine of 62. And let's type this in together. 4.5 times sine of 80 divided by sine of 62. Close bracket. You should get 5.02. And we are in meters. Does that answer make sense? 80 is the largest angle, correct? That's right here. And we should have the longest side from what we know, and it is definitely longer than across 62. So we are good. We did a quick check. We're not just blindly trusting our answer. We're always checking. Okay. I'm going to ask you to try that right away under here. And if I see that you're good to go, I will also show you how to solve for a missing angle today. Okay, so I want you to try based on what I just did. When you think you're stuck, just solve for something that you can before you even get started. Once you solve for side A, also go side B if you can. I'll solve A first. C is your third angle, you've got 2. Let's figure out what that is. 65. Okay. Maybe I'll make a note. No pair. Right? But this is an ASA, right? So basically the side connects the two angles. When you have that, it's going to be sine law, right? Find third angle. And just from the letters, you've got two angles, right? So that's another indication that you can find a third angle. So here it is. This is step number 1. Once you have the 65 in here, you have that pair. Okay? And that's the one I always start with. I start with my pair. So sine of 65 over 14.5 meters. Sine, oh, now you can choose, right? But if you want to solve for side A, you have to use angle A. Okay, so that's going to allow you to do that. Sine of 30 divided by sine of 65 is 8, basically, if you round it to 2 decimals. So there you go. But if I asked you to solve for side B, you start with the same pair. I would always start with the pair that I know, that I was given from the very beginning. But listen carefully here. You technically have another pair now, correct? Once you find the 8, 30 and 8 is also a pair. Could you use that one? But did you round? You did round, didn't you? 7 point. So you will lose some accuracy if you do that. So I would always go back to the original. That's what I would do. Okay, so sine of 65 over 14.5 and then sine of 85 over side of B. So this is B, across from A is A, right? So it's always you're always dealing with opposite angles. Are we expecting B to be the longest side? We do, because it's 85 degrees, right? So a couple things to keep in mind. So 14.5 times that divided by sine of 65. So B is 15.94 meters, which we expected. This triangle is now solved, right? Triangle is solved. You solve for all 3 sides, all angles. So this triangle is considered solved. So if I ever ask you to solve the triangle, that's what it means, solve everything. Okay. And when you feel like it's overwhelming, just focus on one thing at a time. Can I warn you already? You might think you can't do it. And you're just like, what can I do right now? And then work towards the final ultimate answer. All right, let's keep going. Angles. How to solve for angles using sine law. Turns out that it starts off the exact same way as before. The start is the same. It's just what we do later on that changes. So when you're trying to solve for angles, this is on page 5, if you're following, you have sine inverse that you need to use here. So I'm changing this up to sketching, actually having to sketch before we solve. Oh, this is also foreshadowing. Can you notice a pair without graphing it? You see angle X and side X. They're opposite each other, right? Hey, we've got a pair. What are we going to use for this one? Sine law. Guaranteed, right? Guaranteed sine law. Sketch using the triangle, then calculate the values of angle Z and Y. So let's go ahead and do that. Angle X. So this is triangle XYZ. So X, Y, Z. X is 34. As side X is 6.2 centimeters. And side Z, angle Z, I placed it here, so this is 3 centimeters. Have to be careful, but yeah, that's why I ask in this order. Okay. So first and foremost, we have a pair. We already knew that, right? We already knew that. So we're going to go, I'm going to start over here. Sine of 34, let's start with our pair right off the bat. 6.2 centimeters is equal to. Okay, let's almost forget about that they're telling us to find angle Z and Y. Let's forget about that. What is the only angle I can solve for right now? If this is given to me, the only option I have is to solve for the angle across that side. That's all I can do. Notice that Y, there's too much missing, right? I don't know the side length, I don't know the angle. So even if you wanted to, you couldn't do it. Right? So you had to find Z first. So the 3 centimeters goes down here. Very important to place it in the right spot. And then Z is what I'm trying to find. So some students just put down Z. It's sine of Z or Z, whatever you want to call it. So that's how you set it up, okay? And so the angles are always glued to sine or cosine, whatever we're going to be doing here. So this is our variable, so we cross multiply and divide. Okay, so we multiply, then divide. So watch this. You ready? Don't drop the sign. You just say sine of Z is equal to 3 times sine of 34 divided by 6.2. And I will figure out what that is right next to it. It's okay to do this. 3 times sine of 34, close bracket, enter, divided by 6.2. That's what you get. So just write down a few decimals. I don't want you to round. Just go dot, dot, dot like that. Let me zoom into that part because that's where we're at right now. Okay, so what's going to come next? Watch this. This is the critical step here. Now we're going to say angle Z is going to be found by taking the inverse sine of that. So you go 0.270 dot, dot, dot. That tells me that you're using all decimals, okay? And now we're ready to state our final answer. Word of caution. This better always start with a 0 when you're doing your inverse. If this is bigger than 0, you're going to get a math error. It's going to say can't do it. And most likely is something went wrong upstream, right? You maybe copied down the wrong number, you didn't set it up right, so watch out for that. So you're ready for this? I leave it there. I just go second, press second on your calculator, then press sine, and then just copy paste that value into it. You can't close the brackets, don't have to. And you hit enter, and that's 15.70, right? 15.70 degrees. And now you can solve for angle Y, okay? Now we have two angles, so let's go ahead and do that. Angle Y is equal to 180 minus 34 minus 15.70. And yes, I know what you're saying. Last year, our teachers told us to round degrees, angles to whole numbers, right? I'm pretty sure. We still go 2 decimals, okay? That comes with us in 12 applied as well. The province wants it that way, and until they tell us to change it, we do it this way. So there we go. You can put 30 or 0.3, it's not dollars, so it doesn't matter. Okay. So now we have got all angles taken care of. So we know, right, because of this, triangle XYZ is obtuse. It's great, right? Angle Y is greater than 90. So it makes the whole, it turns the whole triangle. Oh, you can see that, sorry. It turns the whole triangle into an obtuse angle. Angle Y is greater than 90. That's what it says there. Could we solve for side Y now? Yes, we could. I'm going to tell you what it is. You can try it. Because I want to make sure I give you some. And notice what it says in this box here. As you solve for missing sides or angles, you'll be able to solve for the rest in multiple ways. So as you know more information, you could technically go off and find different methods of solving. Okay, so where are we at? Time is almost out here. 6. I'm gonna say pages 6 to 10, but I will narrow it down because, oh, sorry, you can't. But I will narrow it down a little bit so that if you are studying for physics, chemistry, what have you, that you're still, you know what, I'm going to do some of this so at least know what's happening for Monday. So pages 6 for sure. Page 6, I would say notice what it says, it's a multi-step question. That's technically what we just did here. It is a multi-step question. But then, for example, if you go to 7, pick some. Pick every other one, right? So don't do every single one if you don't have the time. Question, page 8. It's still continuing from page 7. Just pick one. That's it. That's okay. But I do want you to do this one at the word problem. I want you to start thinking of word problems, okay? Because that's where we're going eventually. And then watch this, 9 and 10. I'm going to narrow this down. These are where you have to draw your own. So I'm going to say do A on page 9, and then do D on page 10. A on page 9, D on page 10, and then we're kind of meeting halfway, okay? That's it. Thank you, guys.